Okay. So it looks like you can see the slides and stuff. So yeah, let's crack this book open. So paging library. The paging library helps you load large sets of data gradually and gracefully, reducing network usage and system resources. So previously we released paging to API, but the feedback that we got is that, well, paging to API is a good start, but a lot of developers told us that they wanted more. So this is why we launched Paging 3, a complete rewrite of the library based on Kotlin coroutines and flow, adding the features that you asked for, like better error handling, easier transformations of your data, like map or filter, and support for common features like list separators, headers, and footers. We also wanted to make sure that paging is easier to integrate in your app. So this is also one of the features of Paging 3. If you're still developing in Java, I know I mentioned Kotlin coroutines and flow, but paging also has support for RxJava, live data, and listenable features. Okay, let me start by telling you why I like Paging 3 library. When you load data in Pages, there's a lot of things you need to do. You need to keep track of the keys to retrieve the next or previous page. You have to make sure that you're requesting the correct next page when the user scrolls to the end of the loaded data. And you also want to make sure that you're preventing duplicate requests. Well, paging does all of this for you. So there's a lot to like. It also tracks loading state and allows you to display it in a recycle your list item or elsewhere in your UI, and provides easy retry functionality for failed loads. Refreshing your list is also only one method call away. Paging makes it easier to transform your data before displaying it. It offers common operations like map or filter, no matter whether you're using Flow, Live Data, or RxJava. Adding separators with your data is also greatly simplified. We also made several Paging 3 components backwards compatible with Paging 2. So if you're already using paging in your app, then you can migrate incrementally. Okay, let's look at a practical example. So let's say that we have an app that displays all the good dogs. We get the dogs from a Good Doggos API that supports index-based pagination. So let's go over the paging components we need to implement and see how they fit in your architecture. So the examples I'm going to share from now on are going to be in Kotlin, but in our documentation, we have examples in Java as well. So check those out for the Java version. Okay, so paging library integrates directly in the recommended Android app architecture in each layer of your application. In your data layer, and more precisely in your repository, you will work with a paging source or a remote mediator. Then in the view model, using Pager, you create a flow of paging data, which in the UI layer, you will use to bind a paging data adapter to populate a recycler view. Okay, let's look at these components individually, and let's start with the data source. So if you're loading data from a single source, like network, local database, or file, implement the paging source. If you're using Room, then paging source is implemented for you. If you're loading data from a layered source, like a network data source with local database cache, then implement a remote mediator to retrieve and save remote data, and also a paging source for the local database cache. Okay, let's look further a little bit at the paging source and see how the implementation will look like. So paging source is the class that defines the source of paging data and how to retrieve that data from a single source. You will implement the load method to retrieve the page data from your data source. Since load is a suspend function, you can call other suspend functions here, such as a network or a database call. What you need to return from load is the loaded data together with information about next and previous keys, or error if the load failed. When your next and previous keys are given by the network response, like what I have on the screen right now, all you have to do is just pass those in. But if you're using indices, for example, you'll have to compute those yourself. So based on the keys you set and the direction of loading, the paging library will set the value of the key field in the load parameters. So this means that when you have to build a network call, that key is just provided. So you just need to use it. Okay, so often just having one data source is not enough, but rather you want to have a layered data source that loads from both network and database. And using network and database is great. These two components work great together. You get to have fresh data from the network with all the benefits of the local cache, like offline support, fast resume, and decreased network traffic. But implementing this by yourself, we know it's not easy. So we often saw this kind of an architecture where a repository would rely on a connected state, so whether a network is connected or not, to decide whether to get the data from the network or from the database. But there are several problems with this approach. So if you just use a connected flag, you kind of oversimplify the problem because individual requests can succeed or fail. And we're saving data in the database, but we're actually not using it, even if it's present. But we're always requesting data from the network. Okay, so what's a better solution? Well, another solution is to always treat the database as the source of truth for the UI, and only request more from the network on first load or when the data from the database is exhausted. Well, paging 3 was built to support this exact architecture. So here's what we need to do to implement it. First, we have to create a paging source that reads from the database. Here, I'm using Room that supports this out of the box. All we need to do is return a paging source from the DAO query. Then, to request data from the network and save it, paging offers the remote mediator class. This load method will be triggered whenever we need to load more data. So here, we will request data from the network and save it to the database. Well, to request data from the network, you need to construct the key for it. So while paging can't really know what the key is, it will give you the tools you need to compute it via these two load parameters. So via the load type and the paging state. So let's look a little bit at these two parameters. So load type gives you information about where we're trying to load data based on the data that's been displayed so far. So for example, load type refresh is going to be called for the initial load. So when the refresh, for the initial load, when refresh was called, maybe from a pull to refresh, for example, or when paging source was invalidated. Then load type can also be prepend when we scrolled up, or append when we scroll down and we need to load data, when we need to append data at the bottom of our list. Then the other parameter of load is the paging state. Well, paging state actually gives you several pieces of information, but out of all of these, there's one that I really find important. And this is the list of loaded pages until then. So this means that you'll have access to all the pages that were loaded in the database. So now that we have the pages that were loaded in the database, means that we can compute the pages that need to be requested next. So for example, if we're appending, we rely on the last item that was loaded to compute the next page key. Or if we're prepending, then we rely on the first item of the first page that was loaded. So after we compute the key, we can just request data from the network and save it in the database. So after we save the data in the database, we'll also have to inform paging whether there is more data to load or not. So for example, if there are no more doggos in the database, there are no more doggos back from the service, sorry, then we know we've reached the end of the list. So this means that we'll just return a success with end of pagination true. And similarly, we will have to tell paging whether an error occurred when retrieving the data. And that's all. That's all you need to do when implementing a remote mediator. So now I looked at the repository layer. Let's look at the view model layer. So let's see how we can configure paging to use these data source. So the primary entry point for paging is the pager. We construct the pager based on a paging configuration and the function that creates a data source. If you're using a remote mediator and the database is your source of truth, make sure you pass them both like I have here in the slide. Paging config allows you to set several parameters, but page size is actually the one that's mandatory and represents the number of items loaded at once from the paging source. So you'll decide on the paging size, on the page size based on how your UI looks like. So in general, we recommend having at least 3 screens of data to ensure that you're doing like an optimum number of requests, not too many, but not too little either. So let's go a little bit more in depth with paging config and see all the other parameters that can be configured. So another one is the prefetch distance. So this one defines how close to the end of the list should the request for the next page should be triggered. By default, whenever we are at page size distance to the end of the list, paging will trigger a new request. Then whether we should enable placeholders or not. So let's see what this means, because I think this is actually a quite interesting approach. So usually what you would regularly see in an app is something like this. So your list gets loaded and you see that your scroll is quite big. But then as you're scrolling towards the end, you're loading more data, and then your scroll bar becomes smaller because the data has been loaded. Well, if you enable placeholders, the scroll bar size will be correct from the beginning. And then if you're scrolling towards an area where items haven't been loaded yet, you will just get null items back. So this means that in your adapter, you will know, well, if I have a null item, then this means that I should display a placeholder. And then whenever paging is able to load that new data, it will emit a new list with the right elements populated. So placeholders, using placeholders has positives and negatives. So the good thing is that users can scroll past what's loaded, and the scroll bar just looks correct from the beginning. And also, you don't need to show a loading spinner separately and take care of all of that functionality, because placeholders are the ones that show the user that you're still loading that data. But on the other side, the problem with placeholders is that items need to be should have the same size. So this wouldn't support items that have different sizes. And your adapter needs to know how to handle null items. And I think the most important one is that this placeholders only fits for paging sources that can count items. So if you have an infinite scrolling list, this isn't really possible. Okay. Then another configuration is initial load size. So this is the number of pages that should be loaded at the beginning, then when you're first opening the application, for example, when you're first loading your data. Another one is max size. So by default, paging will keep in memory all the data that needs to be displayed. But if you know that you have a really large set of data, maybe an infinite scrolling list, you probably don't want to keep all of that data in memory, but rather you want to tell paging that it should only keep a specific amount of items, I don't know, 1,000 items maybe in memory. This is something that you would have to decide based on the items that you need to display. Yeah, so this max size allows you to configure how many items are kept in memory by paging. And then the last one is the jump threshold that's related to when you're scrolling past items that haven't been loaded yet. This is quite a lot. And actually, this is what I like about paging. The fact that by default, if you just want to use it for simple cases, it's quite easy. You just set the page size and that's it. But then if you want to have some extra, more advanced configuration, paging allows you to do that. Okay, so I said that paging works with Kotlin coroutines. So this means that when you're constructing your pager, you can return flow, but pager can also return a flowable or an observable if you're working with RxJava 2, or live data. Okay, now that we've constructed our flow of paging data, let's see how we connect it to our recycler view. So to do this, we will implement a paging data adapter. This actually doesn't look any different to how you would implement a regular list adapter. But under the hood, it provides the functionality needed to support paging data objects. Okay, what do we do in our UI? So in our activity or fragment, you would just collect the flow and then submit the data to the adapter. That's all. So for example, this in an activity. So we're launching a new coroutine in the lifecycle scope, and then we're collecting the latest emissions of the flow and then submitting the paging data to the adapter. So this is how each of the paging components integrates in your AMP architecture. But often we want to perform some transformations to the data before displaying it. Well, transforming paging data streams is very similar to the way we would work with any other data stream. So let's say that we only want to display playful doggos. Well, to do this, we need to map the flow and filter the paging data. That is all. If you're working with streams, probably you will do something similar to filter other streams. Now, let's say that our list is ordered by breed. And what we want to do is to insert separators and to be able to separate the dogs by breed name. Well, when adding list separators, we transform the paging data to insert separator objects into the list. But this means that now our UI needs to support multiple data types. It needs to know how to display a separator and how to display a doggo. So to do this, we create a new UI model that defines a doggo and a separator item. So then we need to transform our separator items. First, we need to transform our items. So first, we need to transform the flow of dogs into a flow of UI model of doggos. Next, to be able to modify the list to insert separators, we again transform the list, we call map, and then we call insert separators. So here for insert separators, we actually get a callback for each individual pair of items. So then we can decide whether do we want to insert a separator between them or not. So here, for example, I'm checking whether the name of the breed between two items is different. And if it is, then I'm just inserting a new separator. Okay, so we've added separators, but let's say that we want to add a header or a footer to our list. So how do we do that? How do we add that header? Well, the first thing we need to do is actually expand the UI model to support the new view types. So to support the new header and footer, we need to display as part of the list. And then we just transform the paging data to also insert the header item and the footer item. Okay, inserting a header or a footer is not that complicated, but what if in our footer, we want to display the load state? So let's say that we want to display a progress spinner while the list is loading, and a retry button for error. So these load elements are actually separate from the actual list content, right? They don't have any connections with the dogs that we want to display. So this means that we don't need to modify the list to add these load related items. So to make it easier to work with a load state object, paging offers a new recycler view adapter type, load state adapter. So to be able to support loading headers or footers, you'll have to implement the load state adapter. So here you would just have to create your view holder, and in your view holder, you will need to know how to react or what to display in different load states. And then you'll have to update the adapter in your UI to also add the footer item, the header item, or both header or footer item. So that's all. But what if you want more flexibility? Let's say that we do want to display the load states, but not inside a header or footer. Let's say that for loading, you want to hide the list and show some fancy doggo animation. Or in case of error, you want to show a retry button, or maybe you want to show a snack bar for error. And then only after you finish loading data successfully, you want to show the list and hide the progress indicator or retry button. Even more, you might want to have different behaviors depending on where the data is coming from. If it's from a paging source or from a remote mediator. Maybe if it's coming from a remote mediator and you get an error, you want to show something to the user saying that, hey, you don't have any internet connection, go somewhere where there's better reception or something. Also, not all load types are the same. So maybe you want to show different messages depending on where you want to load the data. So maybe if you have an error loading data for the first time in refresh, you might want to show the data differently. So paging gives you all of this flexibility and gives you information about all of these load states. And it does that in a load states listener. So you can either implement this listener, but it also offers a flow of a load state. So here, what it does, it returns a combined load state object. So back to our case where we said that we want to only show the list if the refresh succeeds. It means that we are able to decide on the visibility of our list based on the states of the refresh. So if the refresh is not loading, it means that we have finished loading the list and we have finished loading the list successfully without an error, then we can show it. Similarly, if we only want to show the progress bar during the initial load or refresh, then we rely on refresh state is loading. And if you want to show the retry button for error, but only for the initial load or refresh cases, then we check whether refresh is low state error. And that's all. Whew, okay. Going a little bit back to what I was saying with the load state adapter, but also here. So I was saying that you could just display a retry button, but I never actually told you what's up with that retry button. Well, paging provides a retry function on the adapter. So whenever you want to do this kind of retry calls, you can just do it from the UI. But keep in mind that retry only retries failed loads. So if your network call maybe was successful and you're calling retry, nothing will happen, only if error was returned. Probably if you're trying to do retry, even if data was returned successfully, you actually want to do a refresh. So refresh is the function that will actually trigger a reload from scratch completely. And what's important to note is also that this doesn't affect prepend or append state, only refresh. And this should be implemented for UI-driven refresh signals. So this means that this is something that should be called when you have a refresh button, in your UI, or when you're implementing a pull to refresh functionality, but not somewhere from your data or business layer, but just from the UI. Whew, okay, so we've seen all of these types of transformations of paging data, but transforming data can be expensive, especially if you have a lot of items in memory and you're not using this max items in the configuration. So you want to make sure that you're not executing transformations on big sets of data on every configuration change when you start collecting the flow, but rather just once. Well, to help with this, Paging 3 offers the cached-in method. The caching should be done after all the transformations have been performed. So after all your map and so on have been performed. So if you're using Kotlin coroutines, then you have to cache the data in the viewModel scope. If you're using RxJava, you'll also have to use the viewModel scope for caching data. So by default, because paging depends on Kotlin coroutines and flow, it means that it will also bring the coroutines artifacts with it. So if you're implementing this in your viewModel, then your viewModel should already have access to the viewModel scope. So even if you're not working with coroutines and rather with RxJava, it should still be easy to pass it. And then similarly, if you're using live data, you can either cache the data in the viewModel scope or in the context of the lifecycle object. Whew, okay, so this was quite a lot. So let's recap a little bit everything I said. So Paging 3 makes it easier to work with large sets of data, whether you're loading from network, from the database, an in-memory cache, or some combination of all of these sources. The library is built with coroutines and flow, making it easy to call suspend functions and work with streams of data. It has built-in APIs to transform data, add separators, headers, and footers, displaying the loading states, and retrying failed requests. And finally, it's compatible with Paging 2, so it's easy to migrate. So Paging 3 right now is still in alpha, so we need your help to make it better. So please try it out. But to try it out, to get started, you can find out more about paging from the Paging 3 documentation or by checking out the code lab and the sample. And then let us know what we missed. Let us know what you need, what use cases you find that you think are not supported by paging by creating an issue on the issue tracker. So that was it. I will close the paging chapter for now. And yeah, I hope the paging library helps you gradually and gracefully load all the good doggos. Thanks for watching. And now I'm hoping we can get some questions.
Yeah, probably like 2-3 minutes to kind of like write the thoughts out. Yeah. You did really well, Florina.
Yay, thank you.
That was a really solid talk. Thank you.
Nice.
Oh,
yeah, question.
I see there are already a few questions.
Yeah.
You can give it a few more minutes because that way people like to upvote them too, and that way it's so democracy, right? Awesome.
Yeah, that's good.
Yeah, you can hop back in if you want. I saw you kind of like he shows up and then it's like I'm out.
I was actually just trying to test my camera. I just turned it back on and then I saw, oh no, I'm on stage.
It's working. We can tell that it's working. Yeah. Questions coming up.
Like this. Oh, we got 8 votes in. That's a pretty high number. Yeah.
Nice.
Maybe you can start.
Whenever you feel, it seems like it's still pretty active. but not
I
much.
see that the questions are adding up, so maybe we can I can start answering and then we'll see. Okay, can we display header? Okay, wait. I will go with the question that became on top now. Okay, with this approach, can the list separators be collapsible? For instance, can all the dog breeds be collapsed and then when clicked on, then expands the dogs in that category? Not that I know of. I have to admit I haven't implemented a collapsible list since the list view era, but I'm not sure. Would be my answer. Sorry. Probably that would be, I don't know, I would try to avoid implementing it as a list of lists. So I don't know, I would have to play around with it to find out. But actually, this is a really good question. Thank you. Okay, I'll go to the next one. Can we display headers with titles instead of simple separators? I wonder what this means. So instead of the separator, you just want to have one header. I'm hoping that can be implemented with add header, or in the separators, you want to set a text. If you want to set a text, you can, in the separators, you can define any text you want. If you're talking about sticky headers, this is not supported for now, not by default. It's not that easy to implement, so you would have to implement this yourself. Okay. How this new paging, sorry, this kept on jumping. Okay, do you have any suggestions for using paging with Firestore? So because paging 3 supports as a paging source anything you want, then I would expect that in the paging source implementation, you can use Firestore. By default, from what I know, Firestore doesn't have a paging 3 support, so you would just have to implement this yourself. But I think it's possible. Okay. How this new paging adapter interacts with concat adapter? Well, actually, paging uses concat adapter under the hood. So let me switch quickly to the slides. So for example, here for displaying load state. So what we were doing in the adapter, sorry, here, we are doing adapter with a load footer and or adapter with load state header. So actually what paging does under the hood is using a concat adapter and adding these new adapters that we're creating. So this means that you can just concatenate it. I would guess you want to add some other stuff apart from the paging list. I guess this should be possible. I haven't tried it, but I expect that it's possible. I will skip the Slack link for now, or should I open it?
No, skip it. That was just for letting people in. Remote doesn't have a good, yeah.
Cool. Are there built-in resolution strategies if local network data gets out of sync? Different order, indices, duplicates, or is it up to you to implement them yourself in your repo or diff callback? Well, local and network data shouldn't get out of sync because the local data, the database should be your source of truth. So this means that your network data should then afterwards be saved in the database. if you want some different strategies, like for example, I don't know, you have to have some conflict resolution, maybe between the data coming from the network and what's in the database, that's something that you would have to implement, because paging can't know how your data looks like and how you want to, I don't know, merge items or things like this. Okay. Is there any way to implement sticky headers out of the box with paging 3? Not for now, but the team consider this, but it's not an easy problem to solve. But yeah, I'll bring this up to the team. Maybe we convince them to implement it. Okay. Paging 2 didn't seem to gain a lot of popularity. Any idea why? Well, I'm happy you liked it, Shalom. I think the flexibility was one of the features that was missing. So the fact that it wasn't as easy as it is now to map data and to transform data. I do know that there were some confusions about the paging source and how different elements fit in your architecture. I'm hoping this is much clearer now, or at least for me, it was much more clear when I started using it for the first time. So yeah. Okay. If you want to keep Android dependencies out of the repository layer or lower, would the view model be the best place to set up the pager based on the flow from the repo? I was actually trying to get this answer now. So right now, paging has like I think a common library, but that is still an Android dependency. Although I know classes like paging source or pager and so on are actually just Kotlin classes. They don't depend on Android. So depends, I would say, depends on how you're actually separating your layers. If you're thinking about module separation or just Android dependencies separation. So the pager itself doesn't depend on anything Android related. The paging adapter, of course, depends on the list, not on the list adapter, sorry, on the recycler view adapter. So there is the part where you would have Android dependencies. But apart from that, if you're just thinking about whether you can write unit tests or not, that should be possible with whether you're working with the pager in the view model or in the repository layer. I hope it helped. Okay, is it running on Kotlin? Yes, actually. So you might have noticed there that even when you were working, when I was showing the RxJava or the live data examples, you had to pass view model scope. So that's because under the hood, what we're doing is actually just converting the flows to RxJava or live data objects. So I don't know, I would say that the backbone of paging 3 is Kotlin coroutines and flow. Oh, how can I remove an item from the adapter? You don't really remove an item from the adapter, right? You remove an item from your list. So this means that you would, I don't know, let's say that you click on a button and an item needs to be removed. This means that you would tell your data source that that item doesn't exist anymore. So this means that the pager will end up, the paging will end up emitting a new flow of items without that new item. And therefore, the adapter will automatically display that list without the item that you've just removed.